Ooh, wasabi, guys. Let's have a race with this very tedious looking integral, I should say. Alright, it's gonna be, this is just straight up a speed bashing race. Okay? We're just gonna, no time limit, just only me and you. See who could get it first. Alright? On your marks, get set, go. Let's see. This is 3 squared. Let's see. This is going to be equal to 1 minus cosine c. So this is 3, 1 minus, so it's c cubed. Okay. So, and then this is 3, negative 3 sine plus 9 c squared s. And this is 9 1 minus s minus s cubed. Okay, all the way. Okay, so our I have I. This is e to the x of sine cube minus 3 squared cosine. So pi. Okay. This is going to be plus 6. Yeah, it's like positive 6 of e to the x sine of x dx, and then minus 9i. So we have 10i here. I have, oh no, that's equal. Wait, I need to double check. Yeah, this is all 0. Okay, so then I is equal to say 3/10 of pi e to the pi minus 1 plus 1. I think that's my answer. Alright, I'm done. Now, did you beat me? 3/10 times e to the pi plus 1? Did you beat me? If you did, congratulations, holy hell. And if you got the right answer, which I hope you did, if you didn't, accuracy. Okay, that's what rushing does to you. But if you did beat me and you got the right answer, holy hell. The mental endurance you have. This is a very difficult speed bashing integral to speed integrate. Okay, but if you didn't beat me, and you know, it's okay. That's normal. That is normal. Okay, I'll show you how I speed bash this very quickly and easily. So let me go ahead and erase all my work, and we'll go through this together on how we can speed bash this integral. Okay, so number one thing that scares us, this sine cube is what gives us butterflies in our stomach. Okay, because that's nasty. Sine cube, integration by parts with sine cube is disgusting. Your brain is probably even flickering like, do you want to integrate this or derive this? Which one? Right? So, very scary to think about. Right? It's just tedious. It's just tedious work. But I like to derive it because deriving is just a lot easier to do mentally, right? So I would derive, and then I would integrate. Now, here, what I would do if I had like an actual, let's say like a dry erase whiteboard, right? Here's what I would do, right? I would naturally, okay, derive this, but then on the whiteboard, what I would do is I would erase sine square. I would I'll actually get an eraser. Erase sine square and turn that into what? 1 minus cosine square, right? And the reason why I want to do that is because you don't want to be doing product rule in your derivative. That's messy, right? So what's easier here is like, okay, well now it's just this. This is just c minus cosine. Sorry, this is just cosine minus cosine cubed now, right? And this is a lot easier to derive mentally. Does that make sense? It's better than doing product rule. You rather just do chain rule rather than product rule, right? So now it's a lot easier. Now you can go ahead and derive again, right? Okay, this is -3 sine, and then with that negative, oh, I'm sorry, don't ignore this negative. Okay, be very careful. Don't put this with this. This is part of the integration by parts thing. Okay, so be very careful with that. Okay, and this is plus 9 cosine square sine, right? And then you do the same thing, right? If you had a whiteboard, a dry erase board, you could change that to 1 minus sine square, or yeah, change that to 1 minus sine square, right? And you get like sine minus sine cube. Does that make sense? And then this whole thing, you can even like simplify this even further. Okay, this whole answer here, this is 6s minus 9s cube. Okay, 6s minus 9s cube. 6s minus 9s cube. All right, and e to the x is e to the x, so it's always going to be the same thing. Okay, now we go ahead, let I. The reason why I'm using I, because I know, oh, I have a sine cube here, e to the x. Oh, this is going to be recursive. That's how I know. So that's why I brought up that I immediately. And so we do this integration by parts, right? E to the x, we have sine cube minus 3 sine squared cosine. We can just write it like this, right? From 0 to pi. And then what we have left here is we have 6s, the integral of sine x e to the x dx. And then we have this sine cube, we have the same thing, I, except that we have that -9, so this is minus 9i. Okay? Now, plugging pi, right? Sine of pi is 0, right? So that makes everything 0. Plugging 0 and sine of 0 is also 0. So this whole thing is equal to 0. Beautiful. Beautiful. All right, we can just add this in. 10i is equal. Now, this is a common integral. We know this, right? We see this integral so many times in our beginner training. So we're just at a point of like, we just kind of memorize it. So 6, this is e to the x over 2 of sine minus cosine from 0 to pi. Okay? And of course, this simplifies to 3. So our answer, we get 3 over 10 as our coefficient. And then here, the whole balance just based on e to the x sine minus cosine. So e to the pi. Okay, but then sine of pi is what? 0 and negative, and then cosine of pi is -1, but that negative cancels out, so it's just 1. And then minus, and then 0, plug in 0, it's 1. Sine of 0 is 0. Cosine of 0 is 1, right? But that negative gets canceled out with this, so it's plus 1. And so your answer should just be 3 over 10 times e pi plus 1. Okay? And this is how you speed bash. This is how you obliterate your opponents. So again, you don't want to do product rule, you rather do chain rule. It's just a lot mentally easier, right? So spam the trig identities, spam the trig identities in integration by parts. It's so much faster, mentally faster. Okay? And then you don't have to easily mess up. Thank God this equals to 0, less mess for us, and then you're good to go. Alright? I hope that helps. Thank you so much for watching, and I'll see you guys in the next video.